Hey guys, we're going to take a look at the open-ended response practice for today. The first one is redoing number 46 from IA4, which some of you may remember, but most likely you don't remember this problem. Mr. Gonzalez has only $42.50 to spend at a clothing store. He wants to buy a shirt that costs $29, including tax, and some bracelets that cost $4.50 each, including tax. Write an equation to determine X, the maximum number of bracelets Mr. Gonzalez could buy. I want to talk about this where it says including tax, because it's something that you're just seeing this year because you just learned really how to include a tax or to add a tax this year. So when a problem says including tax, that means that you do not have to add anything additional onto the number that they gave you, that the tax is already in that number, okay? So don't let that little tag of including tax confuse you. So writing an equation to determine X, the maximum number of bracelets Mr. Gonzalez can buy. And I mentioned this in class on Monday, but if you're given the variable, you have to use the variable that you're given. So for example, because it says X is number of bracelets or maximum number of bracelets, I have to put X down here in my equation. I can't use, for example, B for bracelets, okay? So I have my $29. That's what he already spent, plus the $4.50 for each bracelet times X, which is the number of bracelets, equals $42.50. Okay. So what I'm going to do is come down here, and for the second part of this equation, I am to solve it. Okay. So I'm going to go ahead and rewrite it down here. 29 plus 450x is equal to 42.50. I'm going to subtract my 29 from both sides. Remembering in addition and subtraction, I do have to line up, I do have to line up my decimal points, whereas we don't for multiplication. So I'm left with 1350, and I have my 450x is equal to 1350. If I divide both sides by 450, I'm left with x is equal to 3. And so my answer is that he can buy 3 bracelets. Make sure you have all that down. We're going to move on to this next practice. A sales associate at a fancy clothing store earns a fixed pay of $2,500. Fixed, we know, means base, plus a commission of 15% of her sales. To cover her personal expenses, she hopes to earn at least $8,000 a month, $8,800 a month. Write an inequality that will give the amount of sales the associate needs to cover her expenses. Solve your inequality and graph the solution set on the number line below. So in this one, I actually am told to do 3 things. First, I have to write the inequality. Then I need to solve it. And then I need to graph it. Okay, and I'm just writing that as a little note to myself. So what do I have in my key information box? I have that her base pay is $2,500. I have that her commission is 15% of sales. Okay, and I know that she wants to make at least $8,800 a month. Okay, So I'm going to first set up my inequality. I have 2,500 plus the 15% of her sales, so 0.15x, okay, is equal to 8,800. Okay, so in this equation, the 2,500 is the base pay. That 0.15 is the commission rate, the commission rate. The X is her sales, okay? Oh, and it meant, whoops, it's supposed to be greater than or equal to $8,800, and that's her goal, sort of her goal income. All right, so that's how I got this equation. Now I'm going to go ahead and solve it. I'm going to rewrite this here in the gray ink. Greater than or equal to. Okay. So I'm going to subtract 2,500 from both sides of the inequality. I'm left with 0.15x is greater than or equal to 6,300. I will divide both sides by 0.15. Okay, and I'm left with x is equal to 42,000. Okay, so she needs to make $42,000 in sales to get to her goal. She needs to make 42 in sales. All right, and so let's pop down to this number line all the way down here. Okay, so I'll put my 42,000 here. All right, and so she needs to make greater than or equal to 42,000. So also 41,000, 42,000, 43,000, and when I have a greater than or equal to, I know that my circle is filled because it could also be 42,000. I'm pointing this because it's when I go greater than, and I'll put an arrow there just to indicate that it could go on and on and on, and it would still be a correct answer. Okay, let's keep moving with our open-ended response practice. All right, Jesse opened a savings account with a deposit of $70. Deposit is what he put in. He deposited an additional $10 each week. Part A, write and solve an equation that can be used to determine the number of weeks Jesse has to make deposits for the money in the account to equal $200. Show your work and remember to include units. All right. So we're going to have to write and solve an equation. Okay, so we opened the account with $70. Sorry, open account. Here's this. $70 to open the account. And we know that he did $10 per week after that. And we want to find out how many weeks to $200. Okay, so I'm going to set up an equation. I'm going to have 70 plus $10 times W is equal to 200. Okay, so what do all of these things mean? 70 is the deposit. $10 is the weekly deposit. W is the number of weeks okay? And the 200 here is sort of the goal, all right? So I'm going to subtract 70 from both sides, all right? And I'm left with 10W is equal to $130. If I divide both sides by 10, we know that he needs 13 weeks, okay? He needs 13 weeks. Okay, moving on to part B. Jesse now has $200 and his goal is to buy, Jesse now has $200 and his goal is to buy a bicycle that costs $375. He earns $10 for every car that he washes. Okay, so he's apparently started a car wash. Write an inequality that represents the number of cars Jesse must wash in order to afford the bicycle. Then solve the inequality to determine the number of cars Jesse must wash in order to avoid the bicycle. Show all your work and remember to include units. So here's my issue. My issue with part B of this problem is write it down in a box on your paper, and anybody who can write down my issue with part B of this problem, why I think it is not possible to totally know if you've accurately solved it. If you can tell me that, then I will give you 4 academic points. All right, good luck.